Hello my lovely students, welcome to yet another video on my channel Mathematics Made Easy. And in today's video we are going to be doing the topic of finding roots and zeros of polynomial equations. So let me give you the learning objectives of today's session. In the session today, you are going to learn about a very important rule which is called Descartes Rules of Signs. And we are going to be using that rule to determine the numbers and types of roots of polynomial equations. So let's get started with solving polynomial equations and finding their roots using Descartes' Rule of Signs. Okay, so let me first read out for you loud and clear the Descartes rule of sign. So if you are given a polynomial function of this form px, as you can see, so p of x is a polynomial function in x, the variable is x here, and as you can see it's a polynomial function with degree n and it is having real coefficients. So an, a1, a0, all of these are real coefficients. That's important. In order to say how many number and type of roots this polynomial function is going to be having, we can use this very important rule which is Descartes' rule of signs, and it is named and made by a very famous mathematician Descartes. So the first part of this rule says the number of positive real zeros of px. So if you have this polynomial function and you are given the coefficients and the degree of a function in a question, then you are going to look at how many number of times the sign of the coefficients of each of the term in this polynomial is changing. If this is changing say 4 times, then the number of positive real zeros of px is going to be 4, or it can also be less than by an even number. So it means it can be of the form 4, 2 and 0, the minimum. Okay, so next is the number of negative real zeros. Now in order to get and say about what is the number of negative real zeros, you are going to be using p of minus x. So this is just the same polynomial px where we have substituted in place of x negative x. So it will be an negative x to the power n plus a1 negative x plus a naught. So now you are going to look at the change in sign of this polynomial p of minus x. The number of negative real zeros of px will be same as the number of changes in sign of the coefficients in this p of negative x. Or again, just like the first one, it can be less than by a even number. So this is what is Descartes rule of sign, and it will become better for you if I take an example. So let me do one question on this rule. Okay, so let me read the question. This is an application of the Descartes rule. And how do you know that you are going to be applying this rule? You have to read the question very carefully. So state the possible number of positive real zeros, negative real zeros and imaginary zeros of hx. So this is the polynomial hx given to you. We have to say how many number of positive, how many number of negative real zeros and finally imaginary zeros this polynomial is going to have. Let's look at the polynomial. I'm going to write it once more for you. So step 1 is to count the degree of the polynomial. So what is the maximum power? I hope you all can notice that the maximum power here is 5. So therefore the degree of hx is equal to 5, which tells you that this polynomial is going to have a maximum or a total of 5 roots. Okay. Now some of these roots might be real, some of them might be imaginary, some might be positive, some might be negative. So that is what we have to be finding now using the Descartes rule. So let's do it. So for step 1, we have to notice how many times the sign is changing in the coefficients. So let me write the coefficients first. So here it is 2, here it is 1, then 3. So all these are positive. Let me write 2, 1, 3. So no change in sign, all are positive. Next is negative 4. So now I can see a change of sign happening. Then negative 1 and then finally the constant 9. So now I'm going to see how many times. There is no change in sign here. Both are positive, so we will not count. Next is also positive. So one change definitely is happening here. Then from negative to negative, no change, and then negative to positive, one change. So there has been a change of sign in the coefficients of hx two times. So what we can say from here, if we apply the Descartes rule of signs, that the number of possible positive real zeros, let me write number of positive real zeros are going to be 2 or less by a even number. So 2 or 0. Okay, that completes the first part of Descartes. Let's move to the second part. So we need h of negative x. So wherever there is x in x, let's put a negative sign. So I hope you can understand that when there is negative, the odd power will give you negative sign. So 2 of, let me first just substitute and then we'll come to the sign. So negative x to the power 4 plus 3 times negative x to the power cube minus 4 times negative x to the power square minus negative x plus 9. So I've just done substitution here. Let's simplify a little bit. So because it is negative x and the power is odd, so it is going to be negative. Here it is negative x, but the power is even, so the negative will become positive. So x to the power 4. Next term, negative x to the power cube, it is still going to give you a negative sign. Negative x to the power square will become positive, but there is a negative x outside, so not to forget, so that will still be negative 4x square. Negative and negative will become positive, so this is going to be the final thing. Now let's notice the change in sign. So negative 2 to plus 1, that's one time it is changing. Again it is changing here from positive to negative. No change at this place, and again from negative 4 to plus 1, so change again. So 1, 2, 3, there are 3 times that the change of sign is happening. So because the change of sign here now is 3 times, so we can also decrease by even number. So therefore we can conclude by Descartes' second point that number of negative real zeros will be either 3 or 1. So this is one part where we have got the positive real zeros and negative real zeros. We still are left with imaginary zeros. So for that, now we are going to proceed to the next slide and tabulate our answer. Okay, so now to tabulate our responses, we are going to draw a table. This table will have the first column as the positive real zeros. Okay, this is the first column. Then the second column will be the negative real zeros. What can be the possible options? We are going to just tabulate our responses. And then we also need the imaginary zeros. So we will have the third column dedicated to the imaginary zeros of the polynomial. And finally, to just sum it up, if we add all three of these, we are going to get the total zeros or the total solution or the total roots of the question. So let's see what options we have. I'm going to now make some rows. Let me add some rows to this table and then we will just summarize our final answer. Okay, so from the previous slide, I hope you were observing because the degree is 5, so there is going to be a maximum or a total of 5 solutions or 5 zeros. So this total will always be 5. That's one point. Now for positive real zeros, from the last slide, we have got two options. Either it can be 2 or it can be 0. For the positive part, and for negative we got the two option, either it can be 3 or it can be 1. So let me just write 2 or 0 and 3 or 1. So there are two options. Let's write each option one time. So for 2, if positive is 2, there are two options, 3 or 1. And if the positive is 0, one more, there are two options again, 3 and 1. So that means our table will have 4 rows of roots. Okay, so now I'm just completing the table. Now, the total zeros have to be 5. That is fixed for us. So 2 plus 3 already is 5. That tells you that the imaginary zeros have to be 0 in this first point. So now we are just adding it up. So 2 plus 3 plus 0. Yes, it is 5. So that means this is correct. Now 2 plus 1 is 3, but we need a total of 5. That means this has to be 2, the imaginary zeros for this case. So now you can add and check. 2 plus 1 plus 2, yes, it is 5. So we are correct. Again, for the next part also, the total zeros have to be 5. This is 3 already, so 2 here. So 0 plus 3 plus 2, and yes, that is giving you a 5. So you are correct. Finally, the last part where you have 0 positive, 1 negative, so therefore 4 imaginary, so 0 plus 1 plus 4 equal to 5. So that now summarizes the table. That means if now we have to write our final answer, then the number of positive real zeros. How many options it had? It had only 2 options. Either it can be 2 or it can be 0. So 2 or 0. Number of negative real zeros. So there are 2 options, 3 or 1. And finally, last part, number of imaginary zeros. So what are the possible options? There is 0, there is 2 and there is 4. So it can be 0 or 2 or 4. So that is the complete solution of the guided practice question on Descartes. Very, very important rule and very helpful for all grade 10, 11 students. So make sure you revise and try a few questions on this. For your exams, this is going to be a very important topic from where you will get many questions. So please practice and revise Descartes Rule of Signs. Let's take one more example, and here you are going to be using synthetic substitution to find all the zeros. So we are going to be taking a mix of Descartes along with the topic of synthetic substitution. Now I hope you girls have revised from the previous video which had put on synthetic division, how to use it to find the remainder, how to use it to find the question. So a little bit of that we are going to be using here. So let's start. Step 1, you have a polynomial function given. What you need to do, you need to find all the zeros. So let's count the degree. Degree is 4, therefore the function will have maximum 4 roots or 4 zeros or 4 solutions. So let's do the step 2 where we are going to be definitely using Descartes' rule of signs that I've taught you in this video today. And so we are comparing the signs of fx and sign of negative fx, f of negative x, sorry. So fx is changing sign how many times? 1 and 2. So because there are 2 sign changes in the coefficients of fx, we know that fx, this function is going to have positive real zeros, either 2 or 0. Okay. Then for the next one, for the negative real zeros, we are looking at the sign of f of minus x. Again, the sign is changing 2 times here. Therefore, fx has 2 or 0 negative real zeros. Now, in any which case, the total has to be 4. Therefore, you can draw the table in a similar way like the previous question. And for imaginary zeros, you are going to get 2 options, 2 or 4. So till here, you have found only just the number of zeros. Now comes step 3 where you are going to be using synthetic substitution and you're actually going to be determining the real zeros. So let's see how. So first you list some possible values of x and then you check with synthetic substitution the value of fx for real values of x. So just see carefully how I have put it. So we are taking it like a hidden trial where we are changing different values of x. We are starting from some negative values, negative 3, negative 2, negative 1. Then we try 0 and 1 and 2. So for all these different values of x, we are trying to see which comes as a factor of this polynomial so that we at least get one root. And we write the coefficients as usual. So the coefficients of this polynomial, remember, it doesn't have a cubic term. So negative, so 1 is the coefficient of x to the power 4, 0 for x to the power 3, negative 18 for x square, 12 for x, and finally 80 is the constant. So these are the numbers on top. We start with synthetic division or synthetic substitution, and what you get in the next row are these numbers. So here the remainder is negative 37. That tells you it's not a root. So in order to find the factor or in order to find the root, we are using factor theorem. So we need the remainder 0. And we are just randomly choosing some possible values of x. And I hope you all can observe the red row where x equal to negative 2. So in this case, the remainder after doing the synthetic substitution has come out to be 0. So that tells you that x equal to negative 2 is one real solution. Okay, so from the table, quite clear that 1, 0 is occurring at negative 2. So since there are two negative real zeros, we use synthetic substitution with the depressed polynomial that you got at this step. So it was x cubed minus 2x square minus 14x plus 40. Now we need the other. We need the second negative 0. What is that? So we are going to do the same thing, synthetic substitution with this polynomial now. So 1, negative 2, negative 14 and 40 are going to be the coefficients on the first row. Now we are choosing three random values of x which are definitely negative because we need the second negative 0 this time. So I have chosen negative 4, negative 5, negative 6. Accordingly, we repeat the synthetic substitution and you can observe from the red row that x equal to negative 4 again is the next root as it is giving you remainder 0. Okay, so now you have got the second negative 0. So two roots you have got, x equal to negative 2 and x equal to negative 4. Now, what is the depressed polynomial here? What is the question? X square, 1 degree less, definitely, minus 6x plus 10. So this is a quadratic, and I'm sure you all remember from your lower grades the quadratic formula. You can use this formula to find the roots of this quadratic equation. So just to refresh you, x square minus 6x plus 10, this is the quadratic. So you can compare with ax square plus bx plus c. That tells you that your value of a is 1, b is negative 6 and c is 10. So these three just substitute in the quadratic or the discriminant formula, replace a with 1, b with negative 6, c with 10, do the substitution, calculation, and what you get are your complex roots. So one root is 3 plus I, the other root is 3 minus I. So you have got two negative and two imaginary roots. These two are real, negative 4 and negative 2, and the remaining two are complex roots. So that's all for the video session today. Please revise today's class and I'll be seeing you in my next video. If you liked the video and found it useful, then please don't forget to like, share and subscribe to my channel Mathematics Made Easy. Bye students.